So, what if I told you there's another you out there? And I don't just mean someone who looks a little like you. I mean an identical copy, living a life that was exactly parallel to yours, right up until this very second. That's the wild idea at the heart of the multiverse, and we're about to dive in and see just how real it might actually be. I want you to really think about that for a second. Imagine a person, a perfect duplicate of you in every single way, living on another planet that's also called Earth. They have lived your exact same life, made every same choice, until just now. At this moment, you chose to watch this explainer. They chose to do something else. Sounds like a sci-fi movie, right? Well, you might be surprised to find out that this isn't just a story. It's a direct prediction from our best, most tested models of the cosmos. Okay, so to get our heads around this, we're going to climb what's basically a ladder of weirdness. We'll start on the most solid, grounded rung and work our way up to the truly mind-bending stuff. We'll look at infinite lookalikes, then different cosmic bubbles, reality-splitting quantum mechanics, and finally, we'll ask if reality itself is just math. Let's get into it. Right, so first things first. This idea of having a cosmic twin, it isn't just some fun thought experiment philosophers kick around. No, it's a direct consequence of our leading scientific theory of the universe. You know, the one that perfectly lines up with every single piece of evidence we've ever observed. The framework for this whole journey comes from the brilliant physicist Max Tegmark. He came up with this amazing way to organize parallel universes into a 4-level hierarchy. Each level gets progressively weirder and more different from our own world. This structure is going to be our map as we explore this incredible topic. Okay, let's take our first step onto the ladder, the Level I multiverse. Now, this version is cool because it doesn't require any wild new physics. In fact, it's the most straightforward and, frankly, the least controversial consequence of what we can already see out there in the cosmos. To really get Level I, you first have to understand our own limits. You see, the farthest we can possibly see into space is the distance light has had time to travel since the Big Bang. This giant sphere of visibility around us is called our Hubble volume. But here's the key thing to remember. There is absolutely no reason to think that space just stops right at the edge of where we can see. The logic here is actually super simple, and it's based on two things we've observed to be true. One, space is, for all intents and purposes, infinite. And two, on the grandest scales, matter is spread out pretty evenly. So if you've got an infinite amount of space, but only a finite number of ways you can arrange particles, then eventually, any given arrangement has to repeat. That includes the specific arrangement of particles that makes up you, me, and everything in our world. It's not a question of if it repeats, just where. So what you end up with is this vast, infinite cosmic quilt, and our entire observable universe is just one single patch. Way out there, far beyond our cosmic horizon, are other Hubble volumes, an endless sea of them. Now, some are going to be completely different from ours, but given an infinite number of patches, some are bound to be identical, and in those, there's another you. So, how far away is your nearest twin? Well, the numbers are just staggering. A rough calculation puts your nearest identical copy about 10 to the power of 10 to the 29 meters away. That is a 1 followed by more zeros than there are atoms in your own body. It's a number so huge it barely even means anything to our brains, but it's not infinite. And if it's not infinite, that means somewhere, way out there in the dark, that person really exists. All right, time to climb up to the next level. Now with level 2, we're not just talking about different ways of arranging matter anymore. We are talking about whole other universes where the fundamental constants of physics, the actual rules of the game, could be completely different. This idea comes from a theory called chaotic inflation. So the thinking goes like this. Right after the Big Bang, space stretched out at this unbelievable exponential rate. In some spots, that inflation stopped, creating these little bubbles that became universes, like ours. But, and this is the key part, in other regions it never stopped. It just keeps on inflating, forever, constantly sprouting new bubble universes. And each one could cool down with its own unique physics. Okay, but why should we believe this? Well, check out this great analogy. Imagine you check into a hotel and they give you a room and the room number is 1967. And you realize, hey, that's the year I was born. You'd think, what a neat coincidence. But you'd only think that because you know there are hundreds of other rooms in the hotel. If there was only one single room, it would be a mind-blowing, inexplicable miracle. Well, a lot of physicists see our universe the same way. Its physical laws seem so perfectly fine-tuned for life to exist that it kind of suggests we're just one lucky room in a very, very big cosmic hotel. Okay, hold on tight because this is where things get really, really weird.
Welcome to level 3, the famous many worlds interpretation of quantum mechanics. This level doesn't send us to a galaxy far, far away. It suggests there are parallel realities right here, right now, existing alongside us.
So this is a really important distinction to make. Your level-eyed doppelganger is a physical person way out there in the vastness of our 3D space. But your level 3 copies, they exist in an abstract quantum space. Think of it like a higher dimension of pure possibility, constantly branching off from our own reality with every tiny quantum event. Here's the core idea. Every time a quantum event has more than one possible outcome, the universe literally splits. So in one universe, the outcome is A. In another, it's B. There's no random chance involved. Both outcomes actually happen, each in its own brand new, totally separate world. That means every decision you've ever made, every coin flip, every path not taken, it's all being lived out by a different version of you in another branch of reality.
Now, here's the twist. For all its mind-bending weirdness, the level 3 multiverse is, well, surprisingly unoriginal. It doesn't actually create any new kinds of universes with different physics. All it does is create more copies of the universes that already exist back in levels 1 and 2. So in a way, it's just more of the same, just playing out in parallel. We've done it. We've climbed all the way to the top of the ladder. This is level 4, the most abstract, the most philosophical, and the most all-encompassing idea of the multiverse. This one goes way beyond just physics and asks a really fundamental question about the nature of reality itself. And this is the question that really gets level 4 going, famously asked by the physicist John Archibald Wheeler. Look, if our entire universe can be described by a set of mathematical equations, why those equations? Why not some other set? The level 4 hypothesis gives a pretty radical answer to that question. It says that all possible mathematical structures are physically real. Every set of equations that is internally consistent describes its very own universe with its own unique laws of physics. It's this idea of mathematical democracy. If you can describe a reality with math, then that reality exists somewhere. So after that incredible climb up the ladder of weirdness, we're left with a huge question. Should we believe in any of this? And honestly, it all seems to boil down to a really fundamental debate about what reality even is. It really comes down to one of two big ideas. The first is the traditional view, the Aristotelian view. What we see and feel is fundamental reality, and math is just a clever language we humans invented to describe it. But the second view, the Platonic view, flips that on its head. It says the mathematical structure is the true reality, and our entire conscious experience is just one small, subjective peek from inside that structure. How you feel about the multiverse probably depends on which of those two camps you fall into. And this leads us to a fantastic final thought from Max Tegmark. Critics of the multiverse say it's wasteful and inelegant because it imagines all these infinite, unseen worlds. But the proponents fire back that a single unique universe is actually the wasteful idea, because you need to add tons of extra rules and explanations, many, many words to justify why it's this specific one and not some other. So what's really the more elegant solution? An infinity of worlds or an infinity of words to explain just one? That is definitely something to think about.